All right, let me run through the last problem here just so you guys can see how this works. Okay, remember taking the derivative to go from displacement to velocity to acceleration. We take the integral to, if we know acceleration, to go to velocity and then to displacement. All right, on this last one, remember we looked at it and we said that you're going to have to convert the speed here from miles per hour to feet per second. So we have 66 feet per second. All right. So we can actually do these other two speeds while we're at it. 30 miles per hour is going to be how many feet per second? 44 feet per second. And 15 miles per hour is 22 feet per second. You can actually even just make it proportional to the original. If the original is 66, and we lose a third of that to go from 45 miles an hour to 30 miles an hour, we're going to lose a third of the speed, which would be down to 44, okay? All right, so this is one of those ones, once you do all the preliminary work, the actual questions that they ask are really easy. Okay, it's just a matter of getting the original work to work. All right. Now, it says here we have a constant deceleration. All right, the constant deceleration, that means that our acceleration is negative. Now, you can handle this one of two ways. You can just use the letter A for acceleration and just know that it's got to be less than 0. Or if you prefer, you can actually write negative A. You just need to make sure that you understand that the negative goes along with the answer. If you were asked for example, the acceleration, you would need to say, oh, it's a negative whatever. Okay? So how you handle that is up to you. In the solution I uploaded, I did the negative A. Here, since I'm seeing a number of you just using A, I'll go ahead and use A for this. But I'm recognizing A has to be constant and it has to be less than 0 because it's a deceleration. That means we are decreasing, or our velocity is decreasing, so the acceleration is negative. All right, so let's work on this a little bit here. The 132 feet from where the brakes are applied, it stops. That means that at whatever time that is, our velocity is going to equal 0. Okay? When, and I'll use x for our distance here, when x equals 132. Okay? So that's something that we know. And I don't know what time that is. Okay, so I'll put and t equals a question mark. All right. We don't know what time that is. However, we do know that at the beginning, this is v equals 66 feet per second when t equals 0, and also at this point x equals 0. Because we're starting the time, we're making that our 0 distance, and how long does it take to stop? Okay? So, in order to figure out how far the car has moved when its speed has been reduced to 30 miles an hour, we need to come up with an equation for its speed. So if I know the acceleration is A, then my velocity at time t is going to be given by the integral of the acceleration. So that's simply at plus c. Now what's our initial velocity, our starting velocity? 66. So v of t equals at plus 66. Okay? Now, at this point, I have no way to actually figure out what A is. So I have to think about what other information I'm given. I'm given that at some point I'm 132 feet from where I started, and at that point my velocity will equal 0. Okay? So think with me here. If our velocity equals 0, I can express what time that is. Alright, so if 0 is AT plus 66, then the time is going to be a negative 66 over A. I put the 0 because the only other thing I know is that my velocity is 0 when x is 132. Alright, that's the only other information I'm given here. So, see where we're headed with this. Okay, now I know, at least kind of, what this question mark is. Okay? So now it begs the question, alright, well, what's A? Let's keep going, because we know x is 132 at that time. So let's come up with an expression for, or a function for x. X of t, if x is our distance from when we hit the brakes, that's going to be the integral of the velocity. So the integral of at plus 66 dt is at squared over 2 plus 66t plus the constant. What's the starting position? No? It's 0. The starting position is 0, so I know x of t is simply at squared over 2 plus 66t. Does that make sense? Alright, so now I use what I know. I know at 132 feet, I know the time is negative 66 over A. So A times negative 66 over A squared all over 2 plus 66 times a negative 66 over A. Notice I'm simply plugging this in for t. Okay? And now I finally have an equation that only has one variable. Alright? So, I'm going to use that and I'm going to solve it. I'll let you guys solve it. It's just a quadratic equation. You got to solve this. Or actually it ends up not being a quadratic equation because the a cancels out one of the a's on the bottom. So you solve this and you get a equal to a negative 16.5 feet per second per second. Okay? Alright, so now that we know that, we actually can write the actual function for our velocity. Since a is a negative 16.5, now I know that my velocity v of t is a negative 16.5 t plus 66. Okay? And at this point, you ought to be looking at a and b and saying, well, now that's really easy. I plug in 44 for v and solve for t. I plug in 22 for t, or for v, and I solve for t. Okay? So, if 44 equals a negative 16.5 t plus 66,
77.
what'd you get?
77.
Should be negative 22 over negative 16.5. 1.3? Okay.
And you get the 77.
Does it come out evenly?
How many decimal?
1.3.
Yeah,
Okay. Alright, so alright, if you recognize that then as 1 1/3, go ahead and use the fraction, that'll be more accurate, okay? So, that means it happens we reach that speed at 1 1/3 seconds. So now I know if I plug that into my position function, alright, x of t is the A is negative 16.5, so divided by 2 is a negative 8.25 t squared plus 66t. So now if I plug in 1 1/3 into here,
How is -8?
so there we get x is 73 1/3 feet. And that's our answer for part A. Okay? Then for part B, it's the same process. You just plug in 22 instead of 44 and you get your time. And it was what time?
It's 2.66666.
Okay, so that means it's 2 2/3. Okay, which when you plug it into x of 2 2/3, 117 1/3. Oh, my pen is dead, that's why. Okay. So 1/3. Alright, so the number line, I put it down here. This is part C. They only asked you to plot the points that we found. You can see here, whoops. You can see here, here's our starting point. I like to, you don't have to do this, but I like to put all 3 variables at each point. I didn't need to put the acceleration because it was constant, negative. But here, at our starting point, 0 seconds, 0 feet, we were going 66 feet per second. After 1 1/3 seconds, we had reached the 44 feet per second, which was 30 miles an hour. And we were 73 1/3 feet away from our starting point. After 2 2/3 seconds, we were at 22 feet per second, which was the, what was it, 45, 30, 15 miles an hour? Is that it? But then we had gone 117 1/3 feet at that point, and then at 4 seconds, we were at 0. Okay? By the way, notice this was 1 1/3 seconds, then another 1 1/3 seconds, and then another 1 1/3 seconds. Notice our rate went from 66 to 44 to 22 to 0. We lost 1/3 of the speed every 1 1/3 seconds. Okay? So, that's another thing there. Okay? All right. Any questions? Okay.